This resource considers the equation of a line. We discuss the slope of a line and find out how to find the slope between 2 points. We look at the 2 primary formats for the equation of a line. We discover the steps to write an equation of a line in point-slope form and go over an example fully. We then look at the steps for writing an equation of a line in slope-intercept form and go over an example in detail. We finish with a summary of the 2 equation formats and how to write each. The slope of a line describes the steepness of a line's tilt. A positive slope means that the line points upward as you read from left to right. A negative slope points downward from left to right. But how exactly do you find the slope of a line? To do so, you need the coordinates of 2 points on the line. The trendy way to describe slope in modern mathematics education is rise over run. More classically, slope is a ratio of the change in y over the change in x. In mathematics, saying change means that you will be subtracting. So to find slope, you subtract the y values for the points in the numerator of a fraction and subtract the x values going in the same orientation in the denominator of the fraction. There are multiple formats for the equation of a line. The format chosen depends on many variables: the available information about the line, instructor preference, and purpose for writing the equation. However, there are 2 primary formats: the point-slope form and the slope-intercept form. The point-slope form is used when you know the slope of the line and the coordinates of a point on the line. If you have the point x sub 1, y sub 1, and the slope of the line is m, then the equation is y minus y sub 1 equals m times the quantity x minus x sub 1. Before we proceed to the slope-intercept form, a note about subscripts in math. Subscripts in math have nothing to do with exponents or any other math operations. They are only counters. So the value x sub 1 means the x value from the first point. Now on to the slope-intercept form. The slope-intercept form for the equation of a line is used when you know the slope and the y-intercept, or where the graph of the line crosses the y-axis. If the slope is m and the y-intercept is b, then the equation of the line in slope-intercept form is y equals mx plus b. The point-slope format is fairly straightforward. First, you find the slope, as we discussed earlier. Next, you pick a point on the line to use the coordinates from. Finish by taking that information and plugging them into the appropriate parts of the general equation. You should note that the plain x and y, without the subscripts, are variables, while the x sub 1 and y sub 1 are values from the coordinates of the point. As always in math, seeing an example helps. Suppose you wanted to find the equation of the line that connects the points 7, 11 and 10, 15. You want the equation in point-slope form. First, you need to find the slope. You want to subtract the y values on the top of the fraction. Because I like to keep things positive, I chose to subtract 15 minus 11. On the bottom of the fraction, you would subtract the corresponding y values. So we do 10 minus 7. Completing those subtractions, we find that the slope is 4/3. Next, we need to pick a point. We decide to choose the point 7, 11. Later, we will consider what happens if we choose the other point. We finish by plugging our information into the appropriate spots of the equation. The x value from our point is 7. The y value from the point is 11. And our slope was 4/3. So our equation looks like y minus 11 equals 4/3 times, parentheses, x minus 7, close parentheses. But what happens if we chose the other point, rather than 7, 11? Let's find out. It seems obvious that the slope would be the same, so our m is still 4/3. This time, we select the point 10, 15. Now, our x value is 10, our y value is 15, and our slope is still 4/3. Now our equation looks like y minus 15 equals 4/3, parentheses, x minus 10, close parentheses. That is one slight problem with the point-slope form. The instructor has two correct answers they have to look for. When you want to find the equation of a line in slope-intercept form, you need to do extra work. Unlike the point-slope form, there is only one correct answer for slope-intercept form. Many of the steps for finding an equation in slope-intercept form are the exact same as with the point-slope form. You still find the slope, pick a point, and plug into the general format. Next, you actually multiply the slope by the x value from your chosen point. Then you solve for b by subtracting that product away. Then, as a final step, you write the equation in its proper form, with the slope and y-intercept written in, but leaving the x and y as variables. For example, suppose you want to find the equation for the line that connects the points 8, 19, and 6, 22 in slope-intercept form. First, you need to find the slope. As I like to stay positive, in the numerator we subtract 22 minus 19. But we have to subtract the corresponding x values in the same order. So in the denominator, we subtract 6 minus 8. Since we have a positive on top and a negative on the bottom, our entire slope is negative. So the slope of our line is negative 3/2. Now we need to pick a point. We choose the point 8, 19. We want to plug into the slope-intercept form, which again is y equals mx plus b. Our slope is negative 3/2, the x value of our chosen point is 8, and the y value is 19, so we plug those numbers into the appropriate parts of the formula. Now we multiply the slope by the x value, so we have negative 3/2 times 8, so we can reduce the 8 by 2 to get 4, and then multiply that 4 by the negative 3 to get an answer of negative 12. Because we want to solve for b, we have to eliminate the negative 12. To do so, we add 12 to both sides of the equation. This means that our value for b is 31. Since we want the equation of any point on our line, we plug the slope and y-intercept into m and b respectively. So our equation is y equals negative 3/2 x plus 31. What if we chose the other point? Well, the slope is exactly the same, and this time we select the point 6, 22. Again, we want to find the slope-intercept form, which is y equals mx plus b. Our slope is negative 3/2, the x value is 6, and the y value is 22. So we plug those values in and have 22 equals negative 3/2 times 6 plus b. We multiply. 2 goes into 6 3 times, and negative 3 times 3 is negative 9. So we have 22 equals negative 9 plus b. We want to solve for b, so we have to eliminate the negative 9. To do so, we add 9 to both sides of the equation. When we do so, we get 31 equals b. So our final equation is y equals negative 3/2 x plus 31, which is exactly what we got when we chose the other point. Equations for lines take different forms depending on what information you have available, or what purpose you will use that equation for. The point-slope form is very basic, providing the slope and the coordinates of one point on the line. To find the equation, find the slope, find the coordinates of a point on the line, and then plug in. The slope-intercept form provides the slope and the value of the y-intercept, or where the line crosses the y-axis. This format is very useful for graphing the line. To find the slope-intercept form, find the slope, find the coordinates of a point on the line, plug in, multiply the slope by the x value, solve for b, then write your equation.